warahmatullahi wabarakatuh. My name is IZZATI BINTI ASRI, and today I would like to present about vector. Before we go any further, I would like to introduce you what is vector. So, vector is known as a mathematical quantity which has both magnitude and direction, which is, we can say that vector has its own direction, which is it can go upward, downward, to the right or to the left, and it has its magnitude, which is the value of the vector itself. So, vector is fundamental in physics, engineering, representing forces, velocities, and displacement in real-world application. For example, we can see if we want to go to one point, if we're from point A and want to go to point B, and point B is located to the right of point A, so we can say, and it took 5 kilometers to arrive at point B, so we can say that the distance to go to point B is 5 kilometers to the right from point B. So it is an example of vector, which it shows that vectors has magnitude and also direction. Okay. So, for today's topic, we will go through two vectors in navigational system like GPS. So, we know navigational system like GPS rely on vector calculation to determine precise location and also movement direction. For example, when driving with GPS navigation, the system will use vector data to calculate the shortest and fastest route. The objective of this study is to explore how vectors improve navigational accuracy and efficiency, ultimately in enhancing transportation and also logistics. So, let's go through to the example. In this case, Mushrif wants to go to Makete for dinner, but he needs to arrive there by 8 p.m. So, at this point, he knows that there are 3 possible routes that he can use to reach Makete, but each route has its different distance, and he will use different travel speed because of each route have different distance. So he need to use different travel speeds to reach at Makete by 8 p.m. Thus, he needs to consider both the length of his journey and the speed that he need to use so that he can travel to reach Makete by 8 p.m. So, there are 3 things that we need to find here. That we need to find the displacement vectors for each route, which is route A, route B, route C, that will be explained later. And then we need to find the shortest distance from these 3 routes and the travel time for each route to reach at Makete at 8 p.m. And we will consider which route that Mushrif should take. So, this is the routes that given, which is we have route A, route B, and also route C. So, for route A, which represents by red line, it starts at 0, 0, at coordinate 0, 0, that was the coordinate for Mushrif's house, and it goes to 10, 4. It goes to coordinate 10, 4, which is 10 kilometers to the right and 4 kilometers upward. And if Mushrif use this route, he need to use average speed 60 km per hour to reach Makete at 8 p.m. For route B, it also starts at his house, which is the coordinate is 0, 0, and it goes to the coordinate 8, 6, which is 8 kilometers to the right and 6 kilometers upwards, and he need to use average speeds of 70 kilometers per hour. And for the last route, which is route C, I'm sorry, route B just now is represented by green line, and route C is represented by blue line. So for route C, it's also start at 0, 0 coordinate and goes to coordinate 12, 3, which is 12 kilometers to the right and 3 kilometers upward. And he need to use average speed 55 kilometers per hour to reach at Makete by 8 p.m. So now, first, we will find the displacement vector for each route. For route A, route B, route C, using the formula B equals to x2 minus x1 and y2 minus y1, which is x2 and y2 represents the coordinate for at the last point, which is Makete, and x1 and y1 is the coordinate of starting point, which is Mushrif's house. So for route A, we will find the displacement vector of it, which is we will make 10 minus 0 and 4 minus 0, which is we will get the displacement vectors for route A is 10, 4. Same goes to route B. Use the coordinate for route B, which is 8 minus 0 and 6 minus 0, which is we get the displacement vectors for route B is 8 and 6. And for route C, we'll make 12 minus 0 and 3 minus 0, which is we will get the displacement vectors is 12 and 3. So next, we will find the shortest distance of these three distances, which is we will find the modulus D. Why will we use modulus? Because the distance should always be in positive and there's no distance in negative. So to find the distance, we will use the formula modulus D equals to square root of x to the power of 2 plus y to the power of 2, which is the x and y that represents the coordinate that we get earlier, which is the displacement vector. So for distance calculation, route A, we will make square root of 10 to the power of 2 plus 4 to the power of 2, which is we get square root of 106, and it's equal to 10.77 kilometers. For route B, also use the same formula, which is it will be square root of 8 square plus 6 square equals to 10 kilometers. And route C, which is square root of 12 square plus 3 square equals to 12.37 kilometers. So by this calculation, we can say that the shortest route is route B, which is it only 10 kilometers to reach at Makete from Mushrif house. So next, we will find the travel time for each route, which is we will use the formula t equals to the distance over the speed. For route A, we will look at the right calculation, which is the right calculation is the calculations that show the times in minutes, and the left one is the calculation which show the time travel in hours. So to make it easier to see, we will use the right calculation, which is the calculation that shows the time in minutes. Okay, so for route A, the distance is 10.77. So it will make it over 60 over 60, which is 60 is the speed, average speed that Mushrif need to use to reach Makete. And why we offer the 60 with 60? Because we know in 1 hour there are 60 minutes. So to get it in minutes, we need to make 60 over 60. So that's why we get the time for route A is 10.77 minutes. For root B, also we make t equals to 10 over 70 over 60, and the time for root B, the time that takes for Mushrif arrive at Makete for root B is 8.57 minutes, and for root C, t equals to 12.37 over 50 over 60, and the time that we will get is 13.49 minutes. So by this travel time calculation, we can say that the fastest route is route B, which is it's only take 8.57 minutes to arrive at Makete by 8 p.m. So we can conclude that Mushrif can take route B, as route B is both the shortest and the fastest way to reach Makete on time. So guys, now we will look up into the application of vector, which is we know vectors plays a crucial role in modern navigation system, particularly in GPS technology, which in enabling accurate positioning and also route optimization. So by applying vector calculations, traveler can determine the shortest and the fastest route by improving the efficiency in transportation and logistics. However, okay, so dalam pepatah Melayu ada mengatakan setiap yang baik pasti ada keburukannya. So despite their advantages, vector-based navigation also has their own limitations and challenges that will affect its effectiveness. So in this topic, we will go through to look at the advantages of vector-based navigation, the limitations of vector navigation, and also the challenges in implementing vector-based navigation. Okay, so we will go through the advantages of vector-based navigation first. So, as we can see, one of the key advantages of using vectors in navigation is precision, which is GPS system is relied on satellite signal and vector calculation to determine exact locations, minimizing travel time and fuel consumption. Additionally, vectors help in real-time route adjustment, ensuring that drivers can avoid congestion or roadblocks by recalculating optimal path instantly. Another benefit is its applicability in diverse environments from urban settings to remote areas where traditional maps might be less effective. So, we as a driver ourselves, we can see that if we use GPS system, let's say we want to go to some place, and by using GPS system, we can look through the GPS which the location of that place and which route we can use to minimize the travel time and also to minimize our fuel consumption, and it also will help us to avoid the roadblocks, the congestion, and so on. So we can say GPS is some things that really helping us as a driver. But don't forget that it also have its own limitation. So for the limitations of vector navigation, one of the major issue is the accuracy fluctuations due to signal interference. Because of we know GPS is relied on the signals, right? So GPS signals can be obstructed by tall buildings, tunnel, or dense forest, leading to errors in vector calculations. That's why if we watch some movies, if there are stuck in the forest or in a route where the right and the left of the route is forest, they will say why there is no line, and they can't find the GPS to go to the hit route. It is because at the dense forest there will be no signal, so that's why the GPS can be opened when they are at the place with fluid points. So additionally, while vector calculation assume ideal conditions, real-world factors like traffic lights, route quality, and weather conditions can affect actual time travel, making the fastest route in theory not always the fastest in precise. As GPS can help us in finding the fastest and shortest route, but GPS cannot tell us which way have the traffic light, or is that traffic light was just started or have started 5 minutes ago and so on. So if we use GPS, the times that have been told in the GPS is not always will be the right time we will use to arrive at our destination, because sometimes the traffic light, or maybe the road quality itself or the weather conditions will make the time that we use to arrive at the destination will be more longer. Next is the challenges in implementing vector-based navigation. A significant challenge in vector-based navigation is in maintaining the satellite connectivity. Since we know GPS depends on multiple satellites, any disruptions such as solar storms or system malfunctions can compromise navigation accuracy. So, another challenge is the integration of vector data with real-time traffic updates. While GPS systems use historical and live traffic data, sudden accidents or route closure may not be accounted for immediately, affecting route efficiency. Additionally, high reliance on digital navigations can lead to overdependence, where users may struggle with manual route finding if system fails. So here it tells that GPS maybe can tell you the live traffic data, but it can tell you if there's a sudden accident or maybe a sudden road closure. The GPS cannot tell us because it was happened by sudden. So we can conclude that while vector-based navigation offers precision and efficiency, it also faces limitations like signal interference and challenges in maintaining accuracy in real-time conditions. So continuous improvements in GPS technology and AI-driven navigation can enhance the reliability of vector-based systems in the future. So in conclusions, for future enhancement in navigation system, maybe AI-driven navigation can improve the satellite technology and maybe reducing signal disruption and enhancing real-time updates and machine learning integration to create smarter, more adaptive GPS systems. So guys, that's all the sharing from me about vectors. Last but not least, again, my name is IZZATI BINTI ASRI, and thank you for lend your ears to hear my presentation about vector. Thank you.